Welcome to UTechspiration channel, where we explore this time a cosmic journey into the rapidly expanding universe of artificial intelligence. Now, when we talk about AI, we're not just talking about some futuristic fantasy of sentient robots taking over the world, although that's definitely a topic for another time. We're talking about a powerful force already transforming our lives, from the way we communicate to the way we drive, and even the way we diagnose diseases. In this odyssey, we'll be your guide through the essential concepts that make up the vast and intricate cosmos of AI. We'll be diving deep into the neural networks of deep learning, unraveling the mysteries of natural language processing, and exploring the frontiers of computer vision. And trust me, you don't need a PhD in astrophysics to understand this stuff. If the universe has taught us anything, it's that the most complex systems can often be broken down into elegant, understandable principles. So buckle up, get ready to expand your minds, and let's embark on this thrilling adventure into the future of intelligence itself. First up is machine learning, or ML, for those who like their acronyms short and snappy. Now, ML is like the rebellious teenager of the AI family. It's all about learning from experience, breaking free from the shackles of explicit programming. Imagine a child learning to ride a bike. They don't need someone explaining every single law of physics involved. They learn by trial and error, by observing patterns, and adjusting their actions accordingly. That's essentially what ML algorithms do. They sift through mountains of data, identifying subtle connections and patterns that would make even the most observant human dizzy. This ability to learn from data is what makes ML so incredibly powerful. It's the driving force behind everything from personalized recommendations on your favorite streaming service to the algorithms predicting the stock market's every move. And let's not forget about the healthcare industry, where ML is helping doctors diagnose diseases earlier and develop more effective treatments. And this is just the tip of the iceberg, my friends. As the volume of data continues to grow at an astronomical rate, the capabilities of ML will only become more sophisticated and impactful. We're talking about a future where machines can predict earthquakes, personalize education, and maybe even write the next great novel. Now, with great power comes great responsibility, as any comic book fan will tell you. And the power of ML is no exception. One of the biggest challenges we face is ensuring that these algorithms are used ethically and responsibly. Imagine an AI system trained on biased data. It could perpetuate and even amplify those biases, leading to unfair or discriminatory outcomes. That's why it's crucial that we develop robust ethical guidelines and regulations for AI development and deployment. We need to ensure that these systems are transparent, accountable, and aligned with our values. Think of it like building a spaceship. You wouldn't just slap on some engines and blast off without careful planning, testing, and safety protocols. Another challenge is the potential impact on the job market. As machines become more adept at performing tasks once thought to be the exclusive domain of humans, it's natural to wonder about the future of work. But fear not, my fellow humans, for history has shown us time and again that technological revolutions tend to create more opportunities than they destroy. Remember the Industrial Revolution? It may have displaced some workers, but it also paved the way for new industries, new jobs, and a higher standard of living for many. The key is to adapt, to embrace lifelong learning, and to focus on developing uniquely human skills that machines will find hard to replicate, like creativity, critical thinking, and emotional intelligence. Next up, we're going even deeper, literally, into the realm of deep learning. Think of machine learning as building a rocket. It gets you off the ground. But deep learning is like strapping that rocket to a spaceship and launching it into the vast expanse of artificial intelligence. It's a subfield of ML that uses artificial neural networks inspired by the very structure of our brains to analyze data with unparalleled depth and complexity. These neural networks are composed of interconnected nodes, or neurons, organized in layers. Each layer learns to detect different features of the input data, from simple edges and textures to complex shapes and patterns. And just like our brains get better at recognizing patterns with experience, deep learning models improve their accuracy and performance with more data and training. Now, deep learning isn't some newfangled technology. It's been around for decades. But it's only in recent years, thanks to the exponential growth in computing power and the availability of massive data sets, that deep learning has truly taken off. It's like we finally gave those powerful rockets the fuel they needed to reach escape velocity. And the results have been nothing short of revolutionary. Deep learning is the driving force behind some of the most impressive AI applications we see today, from self-driving cars navigating complex environments to virtual assistants understanding our every command. It's even helping scientists unlock the secrets of the human genome and develop new drugs to combat diseases. But the true power of deep learning lies in its ability to tackle problems that were once considered too complex for traditional algorithms. Take image recognition, for example. In the past, we had to program computers with specific rules for identifying objects in images. But with deep learning, we can simply feed a neural network millions of images and let it learn those rules on its own. And the results are astonishing. Deep learning algorithms can now recognize faces with accuracy rivaling human vision, identify objects in real-time video streams, and even generate realistic images from scratch. And this is just the beginning, my friends. As deep learning continues to evolve, we can expect to see even more groundbreaking applications emerge in fields like medicine, finance, and even art. Imagine AI systems that can predict natural disasters with pinpoint accuracy, create personalized investment strategies, or even compose symphonies that rival the works of Beethoven and Mozart. But just like with any powerful technology, we need to be mindful of the potential risks and challenges. Deep learning models can be vulnerable to adversarial attacks, where subtle manipulations of input data can lead to unexpected and potentially dangerous outcomes. And then there's the issue of explainability. As these models become more complex, it becomes increasingly difficult to understand how they arrive at their decisions, which can be a problem in areas where transparency and accountability are paramount. It's like trusting a black box to make life or death decisions without understanding the reasoning behind them. That's why researchers are working hard to develop techniques for making deep learning models more transparent and interpretable, so we can trust them to make the right decisions, even in the most critical situations. We humans, we love to communicate. We've developed languages, dialects, emojis, you name it. But what if we could get machines to understand all of this? That's where natural language processing, or NLP, comes in. NLP is the field of AI that focuses on enabling computers to understand, interpret, and even respond to human language. Imagine a world where computers can not only translate languages seamlessly, but also understand the nuances and emotions behind our words. This isn't science fiction, folks. NLP is already powering the chatbots we interact with on websites, the sentiment analysis tools used by businesses to understand customer feedback, and, of course, the ever-evolving world of machine translation. From the early days of machine translation in the 1950s to the sophisticated language models we have today, NLP has come a long way. And as our interactions with technology become increasingly complex, the need for effective NLP will only continue to grow. The potential of NLP is immense. Imagine doctors using NLP-powered systems to analyze patient records and assist with diagnoses, or educators using it to personalize learning experiences for students. The possibilities are truly limitless. But as with any powerful technology, there are risks. Misinterpretation of language can lead to errors, and the ethical implications of using personal data for NLP applications must be carefully considered. Ensuring that NLP systems are trained on diverse datasets and constantly monitored for bias is crucial to mitigate these risks. And let's not forget the importance of clear ethical guidelines for data usage and privacy. As we venture further into the realm of NLP, we must proceed with both enthusiasm and caution. Because when we teach machines to understand our language, we're essentially teaching them to understand us. We humans rely heavily on our vision to navigate the world. We perceive shapes, colors, distances, all in a fraction of a second. Now imagine giving machines that same ability. That's the extraordinary promise of computer vision. Computer vision is the field of AI that allows computers to see and interpret visual information from the world, much like our own eyes do. But instead of retinas and optic nerves, computer vision relies on cameras, algorithms, and a whole lot of data. This technology is already transforming industries. Self-driving cars use computer vision to navigate roads, doctors use it to analyze medical images with incredible precision, and manufacturers use it to inspect products for defects with an accuracy that surpasses human capabilities. From its humble beginnings in the 1960s to its current position at the forefront of AI innovation, computer vision has come a long way. And as we continue to generate more visual data than ever before, the need for advanced computer vision systems will only continue to grow. The applications of computer vision extend far beyond self-driving cars and medical imaging. Imagine using computer vision to monitor crops for disease, track wildlife populations, or even personalize shopping experiences. The possibilities are truly vast. However, with great power comes great responsibility. As with any AI technology, computer vision raises concerns about privacy and the potential for bias. We must ensure that these systems are developed and deployed ethically and responsibly. Transparency is key. We need clear guidelines and regulations surrounding the use of computer vision, especially when it comes to sensitive areas like facial recognition. And we must be vigilant in addressing and mitigating any potential biases that may creep into these systems. Computer vision has the power to revolutionize our world, but only if we approach it with a thoughtful and ethical lens. Because when we give machines the ability to see, we're essentially giving them a window into our world. And it's our responsibility to ensure that window remains clear and unbiased. For centuries, humanity has been captivated by the idea of creating artificial beings capable of performing tasks and interacting with the world around them. Today, that dream is becoming a reality thanks to the rapidly evolving field of robotics. Robotics is a multidisciplinary field that combines engineering, computer science, and AI to design, build, and operate robots. These aren't just the clunky metal arms we once imagined. Robots are becoming increasingly sophisticated, versatile, and capable of performing an astonishing range of tasks. From the factory floors of manufacturing plants to the operating rooms of hospitals, robots are already changing the way we work and live. They're assisting surgeons with delicate procedures, automating complex manufacturing processes, and even exploring the depths of our oceans and the vastness of space. The first industrial robots emerged in the 1960s, and since then the field has witnessed remarkable advancements. As AI and robotics continue to converge, we can expect even more sophisticated and capable robots in the years to come. The rise of robotics presents both incredible opportunities and unique challenges. On the one hand, robots have the potential to free us from dangerous, repetitive tasks, boost productivity, and even enhance our quality of life. However, concerns about job displacement and the ethical implications of increasingly autonomous machines are legitimate and require careful consideration. As we integrate robots into our workforce and our lives, we must address these concerns head-on. Investing in education and training programs to equip workers with the skills needed for this new era of automation is essential. We must also establish clear ethical guidelines and regulations for the development and deployment of robots, especially those designed for sensitive areas like healthcare and law enforcement. Robotics has the power to reshape our world in profound ways, but it's up to us to ensure that this reshaping is for the better. By embracing a future where humans and robots work together, we can unlock the full potential of this transformative technology while navigating its challenges responsibly. We've all seen sci-fi movies with sentient computers, right? Well, expert systems aren't quite HAL from 2001, but they're a fascinating step in that direction. These AI programs are designed to mimic the decision-making prowess of a human expert in a specific field. Imagine a doctor, a lawyer, and a financial analyst all rolled into lines of code. Now, this isn't some newfangled idea cooked up in Silicon Valley yesterday. Expert systems have been around since the 1970s, quietly revolutionizing fields like medicine and finance. They're like the seasoned veterans of the AI world, offering experience and specialized knowledge. Think about medical diagnoses, complex financial modeling, or even geological surveys. Expert systems excel in these arenas, and the demand for this kind of automated intelligence is only growing. By 2025, the market for expert systems is projected to reach a cool $5 billion. That's because businesses and industries are realizing that these systems can streamline processes, improve accuracy, and ultimately boost their bottom line. Of course, building an expert system isn't just about slapping some code together and hoping for the best. It requires feeding the system a vast amount of data, rules, and heuristics that reflect the knowledge of, well, actual experts. It's like giving the system a crash course in a highly specialized field, but instead of textbooks, it's all algorithms and data points. And this brings us to one of the key challenges: keeping these systems up to date. Just like human experts, expert systems need continuing education. The world is constantly changing, new discoveries are made, and information evolves. Failing to update these systems is like relying on outdated medical textbooks, potentially disastrous. That's why developers are constantly working on methods for continuous learning and knowledge validation. It's about ensuring that the expert in expert systems remains relevant and reliable. Think of it like giving your computer a subscription to the most prestigious scientific journals, constantly feeding it the latest breakthroughs. So, while expert systems may not be about to launch into existential debates about the meaning of life, they represent a powerful application of AI, capable of transforming industries and shaping the future of decision-making. And who knows, maybe one day, they'll even surpass their human counterparts in certain domains. After all, they never get tired, they don't need coffee breaks, and they're always eager to learn. Imagine teaching a dog a new trick. You don't hand it a textbook on canine obedience, right? You reward it for good behavior. Well, that's the core idea behind reinforcement learning, a branch of machine learning where an AI agent learns through trial and error, guided by rewards and penalties. It's like giving the machine a digital treat for every successful step. Now, this concept isn't exactly new. It's been around since the 1980s, lurking in the background of AI research, but you know how it is in science, sometimes an idea needs a little something extra to really take off. And in the case of reinforcement learning, that something extra was the rise of deep learning. The combination of these two powerful approaches has unleashed a wave of innovation in fields like robotics, gaming, and even autonomous systems. We're talking self-driving cars, robots that can navigate complex environments, and AI systems that can beat human champions at their own games, all thanks to the power of learning through experience. And the market for this technology, well, it's skyrocketing faster than a SpaceX rocket. By 2025, the global market for reinforcement learning is projected to hit a staggering $20 billion. Now you might be thinking, this reinforcement learning thing sounds great and all, but what about the risks? And you'd be right to ask. After all, with great power comes great responsibility, even in the realm of artificial intelligence. One of the key challenges with reinforcement learning is the potential for unintended consequences. Think about it. If you're not careful about defining the rewards and penalties for an AI agent, it might find creative but potentially disastrous ways to achieve its goals. It's like teaching a dog to fetch by rewarding it for bringing you any object, only to find out it's developed a fondness for your neighbor's slippers. That's why researchers are hard at work developing methods for safe and ethical reinforcement learning. It's about creating robust algorithms, defining clear objectives, and constantly monitoring the agent's behavior to ensure it's learning in a way that aligns with our values. So, while reinforcement learning holds immense promise for the future of AI, it's crucial to approach it with a healthy dose of caution and foresight. It's a powerful tool that requires careful handling, but in the right hands, it has the potential to revolutionize countless industries and unlock new frontiers in artificial intelligence. And who knows, maybe one day we'll have robots teaching dogs new tricks, all thanks to the power of learning by doing. From the algorithms that power our social media feeds to the virtual assistants answering our questions, artificial intelligence is no longer a futuristic fantasy. It's here, it's evolving at an astonishing pace, and it's transforming the world around us in ways we're only beginning to understand. We've journeyed through the landscape of AI, exploring the key concepts that are shaping the future, from machine learning, where computers learn from data, to deep learning, where neural networks mimic the human brain. We've delved into the world of natural language processing, where machines strive to understand and communicate with us in our own language, and computer vision, where they learn to see and interpret the visual world. We've witnessed the rise of robotics, where machines are stepping out of factories and into our homes and workplaces, and explored the potential of expert systems, where AI systems are becoming trusted advisors in specialized fields. And finally, we've glimpsed the exciting and perhaps slightly unnerving potential of reinforcement learning, where AI agents learn through trial and error, constantly pushing the boundaries of what's possible. As we venture further into the 21st century, one thing is clear. The fields of AI we've explored, machine learning, deep learning, NLP, computer vision, robotics, expert systems, and reinforcement learning, will continue to advance at an electrifying pace, blurring the lines between science fiction and reality. But this technological revolution isn't just about algorithms and data sets, it's about us, humans, and our relationship with these increasingly intelligent machines. It's about ensuring that AI is developed and used ethically, responsibly, and for the betterment of humanity. It's about embracing the possibilities while mitigating the risks, and ultimately, shaping a future where humans and AI can coexist and thrive together. Thank you for joining me on this incredible journey through the world of artificial intelligence. Don't forget to subscribe for more explorations into the cosmos of science and technology. Until next time, keep looking up, keep asking questions, and never stop exploring the wonders of the universe, both within and beyond our pale blue dot.